Now let's look at how to calculate the distance between 2 points. So let's imagine I have 2 points, this point over here and this point over here, and let me name those 2 points A and B, and I want to find the distance between them. So point A, the coordinate is given as x1, y1, and at point B the coordinate is given as x2 minus y2. Now for point B, if I draw a vertical line down and from point A I draw an horizontal line and they meet here, I see that this is a what? This is a right angled triangle over here, in which line AB is the hypotenuse and is the desired side. So as we discussed when we were finding gradient, the length B can also be written as my change in y, which is what? Y2 minus y1, and my length A is my change in x, which is x2 minus x1. So now for my Pythagoras theorem, I can write that a squared plus b squared is equals to the length of my diagonal, this length over here, which is what? D squared. And I know that the value of A is x2 minus x1, so I replace it with A, then squared, plus the value of my B is y2 minus y1, so I write y2 minus y1 and I find the square. So the D now, which is the distance between point A and B, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So you have to memorize this formula because this is the formula for finding distance between 2 points. So let's try to solve two examples to see how we apply this. So in the first example, I told to find the distance between these 2 points. So the first thing we have to do now is we have to label the coordinates, and as we've mentioned before, the order does not matter. So I can choose to name here x1 y1 and here x2 y2. On the other hand, you can choose to label it as x2 y2 and here as x1 y1, does not really matter. So the next thing we have to do is just to apply the formula, and we know that the distance is given as the square root of x2 minus x1 squared plus y2 minus y1 squared. So what does that become? That becomes the square root of my x2 in this case is 1 minus, and my x1 is 7 squared, then plus my y2 in this case is 6 minus, and my y1 in this case is 2 squared, and that becomes the square root of 1 minus 7 is minus 6 squared, then plus 6 minus 2 is 4 squared. So minus 6 squared is what? 36, because minus 6 times minus 6 is 36, then plus 4 squared is 16. 36 plus 16 gives me what? Square root of 52. So now 52 I can write in form of what? 4 times 13, and when I find the square root of 4 I have 2, so this can be written as what? 2 root 13. Or if I want to write it in decimal, I can also write it as what? 7.211. So the distance between these 2 points is what? 2 root 13 or 7.211 to 3 decimal places. Now let's look at another example. And here we are told to find the distance between these 2 points. So the same thing we do, we first label the coordinates. So we'll call here x1 and here y1, and we'll call here x2 and here y2. So we know that formula for calculating the distance is given as the square root of x2 minus x1 squared plus y2 minus y1 squared, and that becomes the square root of x2 in this case is what? Minus 2 minus, and my x1 in this case is 3 squared, then plus y2 in this case is what? 5 minus, and my 1 in this case is what? Minus 3 squared, and that becomes the square root of minus 2 minus 3 gives me minus 5 squared, then plus 5 minus times minus is plus, and 5 plus 3 will give me 8 plus 8 squared, and that becomes the square root of minus 5 squared is minus 5 times minus 5, and that gives me 25, and 8 squared gives me 64. So 25 plus 64 gives me what? 89, and the square root of 89 is 9.434, 3 decimal places. So the distance between these 2 points is what? 9.434 or root 89. So this pretty much sums up the procedure for finding the distance between 2 points on the coordinate plane.